No.
Okay, here we go.
That's like what genuinely. Oh, not every. I was like, I don't know what's wrong with this. Like it's not even.
Okay, today we're talking about momentum. By the end of this lesson, you will be able to calculate momentum and be able to calculate impulse and how it relates to momentum.
Basically, it's how you blow stuff up with impact.
Okay, so our last unit of our semester, we're kind of running out of letters. The variable for momentum is a lowercase p. I don't know if it's like a Latin term or like started like momentum, or kind of like opossum. I don't know. I got nothing.
I understand.
Okay, so I want you to think of something that has a lot of momentum. Everybody got something? Okay. My guess is it probably has a lot of mass and it's probably going fast. Okay. Momentum, I think it's kind of intuitive. You've heard the word momentum used, and it's not necessarily used incorrectly. So, more mass, more velocity, more momentum. Heard that?
Just remember the random insulting. I also noticed that in momentum it has the word mom. So
Yeah.
remember the very insulting joke.
Okay. So, the unit for momentum is what's the unit for mass? Kilograms. What's the unit for velocity? Meters per second. It's kilograms times meters per second. Sadly, momentum doesn't have a scientist last name. It just stuck with like kilograms meter per second. Like it's not like a Newton or a joule. It's just
But what does it?
kilogram times meter per second. Okay. Now, what do you think? Do you think it's a vector or scalar quantity, momentum? Does it have direction? Mass does not, velocity does. It is a vector. Okay? And it's determined, it's the same direction as velocity. Which way you are moving. You guys stink. Throwing it out there. Don't overcomplicate that. If you're moving this way, that's the direction of velocity and momentum. If you're moving this way, that's the direction. Sorry, camera. If you're moving this way, that's the direction of momentum and velocity. Good with that? How would you describe momentum in words? So, if you're going into a series against a team that has a lot of momentum, is that a good thing or a bad thing for you? It's a bad thing. Okay, they're on a winning streak. Okay, one way to describe it is how hard it is to stop something.
You can't stop an asteroid that's like 9 miles across.
Okay.
Going at like Mach Jesus. I'm not joking. I can't go that fast.
Okay, how hard it is to stop something. Newton described it as the quantity of motion. Good with that? Good? Good.
Yeah.
All right. Is it possible for a 500 kilogram sports car to have the same amount of momentum as a 10,000 kilogram Mack truck going 20 meters a second down the road? Tell your neighbor. Tell them how.
$200,000 roughly, basically Optimus Prime.
Okay. Yes? No. Is it possible? Yes.
Realistically,
Oh, yeah. Here we go. So mass times velocity. So 10,000 kilograms times 20 meters per second.
sports car.
Okay. So 20,000 kilograms meter per second. The car has a mass of 500 kilograms. Its velocity must be pretty fast.
Realistically, that wouldn't be possible
Well,
based on how I saw it.
if you have, so you have 200,000. Divide that. 400 meters per second. Okay, so that's close to Mach 1, but it is possible.
Yes, but it's just unrealistic and very stupid because it just melted before you even get yourself off the
Okay.
ground. Can I take a picture of that? That is ridiculous. That's not even a car. That's a car that can reach up to 1,000 miles an hour. There is a vehicle that can actually break the sound barrier on the ground. It's just ludicrous.
All right, next question. I'll jump back up.
Yeah.
Tell your neighbor. Wow.
Yeah, because I don't, a lot of like like how.
I'm with that. We're getting good. That's too bad. I have both sides of the story. Is that out?
Correct answer is. Correct answer is C. There we go with that. Has the same acceleration, therefore they have the same speed, but the bowling ball has more mass, and it's going to hurt more when it hits your foot. Good?
It's also going to leave a bigger hole.
Next question.
Oh, no.
I'm sorry.
95 miles per hour. Like,
I wouldn't even call it that.
I didn't work on it.
I do.
Yeah, 100%.
Muffled screaming.
I'm just gonna give you the answer to this one. Everybody got a guess? This one, if they're going this way, this one's going north, that one's going south. They have the same amount of momentum, but because the directions are different, it's gonna be different momentum because the directions are different. You all right with that? Same amount of momentum. But different directions. Adam, that goes to you too, buddy. Okay, good?
What?
What do you got? Neighbor, tell them why.
No, it's not hard. It's not.
Maybe it's not. She asked me what we were doing. I was looking for a game. What?
I said you did it like today and I did it.
I don't want to do everything. That's the one for that. Yeah. I don't want to do everything. Let's get over here to the.
Yeah, this one was quite right.
I'm just not trying to do that.
What?
Dude, she's such a cool. Us take care of her. The good thing is, Katie was studying.
Okay, what do you say? Show me 1, 2, 3, A, B, C, D, E. What do you say?
E.
Okay. Here's a trick. Let's make up some numbers. Let's say this has momentum of 5. So your initial is equal to positive 5, and your final is 0. Yes? So your change in is final minus initial, negative 5. 2 starts at rest, so initial momentum is 0, final momentum is positive 5. Your change in is positive 5. Yes? This one initially has positive 5 kilograms meter per second. and mess that up. And then your final has -5 kilogram meter per second. Your change for this is what? -10. Final minus initial. -10. Yes? Good with that? Gotta watch for direction.
Like the largest? You're like not talking about the magnitude.
Good question.
It's actually-
So the magnitude is the absolute value of. Okay? So like, I don't, this has a greater change momentum than that. Yes, it's negative, but this is the amount of change.
It's like
So-
the magnitude
So
kind of.
E's right.
Magnitude is absolute value.
So E's right.
E is correct.
Okay.
Good with that? Okay? All right. You're following along, I jumped back up. Okay, how would you describe, or sorry, the difference between force and momentum? Okay, they are not the same thing. We could describe momentum as inertia in motion. Is inertia the same thing as force? Is inertia the same thing as force?
Yep. Get how fast it's how like. What about momentum? Oh yeah. Momentum and inertia, it's the same thing.
Okay, so not the same thing. Something can have or possess momentum, just like it can have or possess inertia, but it cannot have or possess force. An object can exert a force, but it can't have it. Kind of a subtle difference in verbs there. I don't know, part of English that is. All right, so you good at that? They're different, not the same thing. So, if a net force acting on an object was equal to 0, what would happen to that object's momentum? What would happen to the object's momentum if the net force acting on the object was equal to 0? Tell you. Tell them more.
I did one practice problem for that.
Correct answer is? What would happen to it? Okay, it would, so you'd have a constant velocity, so your momentum would remain constant. It's gonna do what inertia wants to do. The sum of the forces are equal to 0, inertia's happy, it's like, yeah, okay? So whatever the velocity is, it's remaining that, and the momentum is constant. So, on the flip side, if there's unbalanced forces, if the net force is not equal to 0, the sum of the forces not equal to 0, what happens to momentum? It will change. You all right with that? There will be a change in momentum. Okay? Which kind of begs the question, well, how much will it change by? I mean, that's a good follow-up question, right? It's like, it changes, but wouldn't it be good to know like a quantity or amount or like? Okay, so that is a good follow-up question. Which we shall answer. Okay, so impulse. Impulse. Again, we're running out of letters. We're gonna use capital J for impulse. This is equal to the net force multiplied by the time that the force acts on it.
Isn't capital J juice?
Yeah, I know, right?
Or-
So, capital J, yes, for units is for joules, but for variables, impulse. I know. Usually I write it out impulse, just so not to get things all wonky, okay? So, the unit for impulse what's the unit for force? Newtons. And what's the unit for time?
Seconds.
Seconds. And Newton times a second is the unit for impulse. Okay? Now check this out. What are the primary colors? What are the primary units that make up a Newton? What are the SI units that make up a Newton? I'll give you a hint.
Kilograms.
This is a kilogram times meter per second squared. See where that came from? Okay, kilograms times meter per second squared. Times seconds, math people, simplify. That leaves kilograms times meters per second. Where have we seen that before?
Momentum.
Momentum. What? The same unit as momentum? That's funny. So, this is known, written that a little smaller. The impulse momentum theorem says the net force times time is equal to your change in momentum. So the question that we had on the table was, okay, we know that a force changes momentum, but how much does it change it by? Impulse answers that question. It says, okay, if I take the force, multiply it by the time it takes, or the time that the force acts on that, that's going to equal how much momentum changes by. You right with that? And in this class, we're going to assume that the objects that we're focusing on are not going to change their mass. So we're like walking along, all of a sudden my arm falls off. Like, I hate it when that happens. Okay? We're not changing the mass. The object's going to stay intact. Okay? So change momentum for this class is going to be equal to mass times, so the only way to change momentum is to change the velocity. Right with that? I'm just going to make a connection here with the last chapter. You don't have to write this down. This is just trying to make connections here. It kind of has a similar flavor to work. So work is equal to the net force parallel times distance. It's going to be equal to a change in kinetic energy. we baked up this idea of work to help us describe how force affects energy. We baked up this idea of impulse to help us understand how force affects momentum. See some similarities there? All right. That's up top. So.
Oh.
Tell your neighbor.
Is there also like I said like parallel, like the force is parallel to it? So like
Because work, it gets a little. Math gets a little more complicated. I mean, I could go into it with you if you wanted to, but you probably won't. Okay, correct answer is. Everybody go with B. Experience the same force for more time, therefore you're gonna have a greater change in momentum. Okay, not too hard. Okay, this one doesn't really require physics to know the answer to this. Golf ball is going to take less time. Good at that. But what happens if we give the golf ball the same amount of momentum as the bowling ball? Tell your neighbor. Is everybody okay with the same time?
Yeah.
Huh? Thumbs up when you got something. Tell your neighbor.
we could look at other property. It was like 47.
I don't think it is because this stuff's not
Second, I would say.
the reason it was always 4 times before in the previous unit was because it was velocity squared. Now it's just base velocity, so it should be 2 times, but since there's no squaring anything, that was one.
Correct answer is?
B.
Correct answer is B. Okay, check this out. So we want them to have the same change in momentum. Okay? So if you have half of the force, in order to keep this side the same, we need to cancel this out by doing twice the amount of time. Okay with that?
Yes.
B. Up when you have a guess. Have a conversation and tell them why.
That's why it's half. It's the lighter one. What is half that one? Same amount. I mean, yeah, it's just. Depends on what else. I feel like it's
It's just that as a student, of course, it's a lot of time for like up top.
Yeah, so other classes like
That's includes I'd say like,
there's like practice tests. Is there like specialized practice tests?
I don't think
Oh, there is
so.
specialized.
I don't really care about force.
Like all of the.
Correct answer is?
C. B.
Okay, here we go, ready? Try to answer change of momentum. There are 2 different perspectives. You can take force times time, gives you change of momentum, or mass times change in velocity. Okay? Depending on the scenario, one of those is like a rock solid argument. The other one I'm going to describe as fuzzy. Okay? So if you're like, okay, it's mass times change in velocity, okay, well, this one's bigger and it's gonna go slower. But this one's light, it has less mass and it's gonna go faster. Question? Okay.
No, it's easier to solve.
Okay. So it's like, I don't know. You feel the fuzziness? Like it could be. But if you look at it from this point of view, they have the same force for the same amount of time. They have to have the same change in momentum. Rock solid case. You are trying to be a physics lawyer. Correct answer is B. Okay. Okay. Here's some misconceptions. Ready? Momentum is not just speed. Okay. B is definitely going to be moving faster, 100%. But it's mass times velocity. Okay. Momentum is not just mass. A is more massive, yes, but it's mass times velocity. Okay? You are looking for the rock solid argument. Don't settle with the fuzzy. Okay? If you're feels fuzzy, try a different route. Okay? Thumbs up when you got a guess. Have a conversation, tell them why.
Started when I was like 99% of the time. If there's an option that's like last time, same time, it's always the same.
No.
Like
It's
all
just
I've
why
learned from physics is everything is
Because
nothing
it's
matters.
still over 1 second.
Correct answer is
B.
B.
Pretty good work.
Okay, now, for the same reason, you have the same force, where did that go? Same force for the same amount of time. Now, they'll experience the same change in momentum. B will definitely have more momentum at the end. That's not what I'm asking for. Okay, I'm asking which one experienced a greater change. Here's an analogy. If I give you $20, does that mean everybody's bank account is the same at the end of that?
No.
No. All we know is the change was the same. Okay? Oh. Okay? Hang with me. Keep it in your head. Thumbs up when you got something. Tell your neighbor and tell them why. I want a good explanation.
See.
Why? What's wrong with this?
I'd rather be a dead.
Wait.
Correct answer is
Hey.
A and
C.
okay. Who wins the race? B wins the race. Yes?
Yes.
Why? Because it has a run ahead start. Everybody okay with that? So if somebody wins the race, what does that say about the time that they spent on the racetrack? As less time. Less time. Okay? So A experienced this force for more time than B did. A experienced a greater change in momentum. You okay with that? B has more momentum at the end, yes, but I'm asking for the change. You okay with that? Last question. Thumbs up, you got something?
Did everybody say?
Well, I don't know.
He's gonna go faster.
I think it's.
Mass and velocity walk.
Everything's
Well, mass B is missing the velocity. While for A, well, velocity is missing.
Well, we have moments over break.
They were like, yeah, like higher.
Dude, when my teacher said that, I was like, I'm not. I was like, I was swear to God. I'm not like, I'll have time.
So like they were and this
Like,
one
it's
is
not
faster.
gonna take
But that one, it's not stickers, but.
Correct answer is
I don't know. It's like, so I'm not.
who wins the race? Why does B win the race?
That's fine.
Is less mass, it's going to experience a greater acceleration, it's going to speed up faster. Okay? Therefore, A is on the racetrack for a longer period of time. It's going to go slower, but it's going to have a greater amount of momentum because they both started at rest.
Yeah, but like depending on like what the actual numbers are, since B is gonna end up getting a higher velocity or like change in velocity,
Sure
could
is.
that not also balance out at some point?
Nope, never will. Nope.
Hey, bro, I did good.
Why not?
Why? Because they'll always, like, even if this is like 1,000.
Oh, we're not.
So like,
Oh, what's like a one?
you have 1,000 kilograms, you had a force of, let's just say 1. Your acceleration is gonna be 0.001.
That's your last night.
Okay? And we can do, yeah, let's do this. They have the same racetrack acceleration, that versus like, let's say 1.
Save it. High school is not bad.
That acceleration 1. You're gonna have a small velocity, but when we take, you're gonna have like 1,000 times whatever the velocity is. That's gonna overrun 1 kilogram times whatever the velocity is. What? Hey. Yeah.
Yo, who's my partner?
Yep, here's A. Have a good weekend. You got a worksheet.